So again, we're not worried about plasmas now, right? You will, so I'm telling you, don't get to school. Mr. Bullen said there's only 3. He's a liar. No, I'm not. I just said for now, we're studying solids, liquids, and gas, because that's all that we need to study. And as we start looking at solids, we said that solids have a definite shape, they take up a definite amount of space, and their molecules are very close together. So when I get to the slides, which are like way down the road from this one, I'm not going to spend a lot of time. I remember drawing the little cube, and I remember drawing the little circles inside the cube very, very close together. And I think every time I've talked about solids, I've put my hands very, very close together. And I know if Anna was here, she'd have already done it for me. Right? Because that's the way the molecules inside of a solid look like. We talked about liquids. Liquids are a little bit different. The molecules are flowing. They move around. They have space in between them to move around. That's why when I put ice in a cup, the ice just kind of sits there, and I can shake the ice around, but the ice itself, like the inside of the ice, is not really moving that much, right? I put water in a glass and I shake it around, it sloshes all around, right? What else do you remember about liquids? What are some things, Rachel? They take up a definite amount of space. They don't have a definite shape. They take the shape of their container, right? Whether I dump it on the floor, or I put it in a cup, or I fill up my water bottle, that's the shape that that liquid is taking. Yes? Yeah, the molecules have space in between them, and they're allowed to kind of move and flow over top of each other, right? I know that when we had all of those Orbeez, we said if you could shrink yourself down, when you look at the Orbeez, how you can move the Orbeez around, that's probably what the molecules of a liquid look like. There's space in between them, and they have room to move and flow over each other. What else do you remember? Yeah, they're loose. The molecules are loose and they're moving around. Then we got to gas. Gas does not take up a definite amount of space. It has no definite shape because you can compress it, expand it, and we know that the molecules of a gas are moving around pretty quickly, right? Solids, liquids, and gas. Here's a picture, I guess a close representation of those. Not watching that. Not going to go through that. Nope. And keep on skipping. All right, so did we spend time talking about how solids are close together? Do you notice these little lines? Yeah. That does mean that there is still some movement. It's really weird to talk about it. There is still heat energy inside of ice. Mr. Bullen's ice is cold. I understand that, but if I put that ice on dry ice, isn't that ice a lot warmer than the dry ice? So there would be a transfer of heat. Unless you hit something called absolute zero, which I don't think is possible to hit absolute zero, at least not naturally, where everything stops moving, you're going to have some heat energy. It's just a lot less in a piece of ice than it would be like in a match or something. We talked about liquids. Again, like I said, it's almost like that cup of Orbeez that was up front that everybody had to stick their hand in when they were walking in front when I had that up there. Because it was neat to feel those things moving around you. That's probably what it would look like if we could shrink ourselves down tiny enough to see the molecules, would be something like that. And then in gas, we see that they're moving around very, very rapidly. We all have this in our notes. The only person that would have any excuse would be Noemi, because she may not have been here for this. Were you here for this unit? Were you here when I did solid, liquid, and gas? So solids, liquids, and gas. And we know, if I can find that triangle on here, hopefully it's on here somewhere, we can bounce around from solids to liquids, liquids to solids, liquids to gas, gas into liquid. Those are all normal. Going straight from a solid to a gas was pretty weird. I think that was probably some people's favorite experiment this year when I brought in the dry ice. And going from a gas straight into a solid, we see that when we see frost forming on windows. With desublimation is one that I think everybody liked. But this first one, I don't think is very hard. It's melting. We all know what happens when something melts. I leave the ice sitting on the counter, and it melts. It turns from a solid into a liquid. Do I need to add heat or lose heat for that to happen? You have to have an adding of heat. Because if I drop a piece of ice in the freezer, does it melt? No, it just sits there because there's no heat exchange going on. Maybe. Boiling. I put water on the stove. I'm obviously adding heat. The more I add heat, those molecules start to move faster and faster. When they move far enough apart, they change from a liquid into a gas. What's that process called when water turns from a liquid into a gas, Kaylee? Evaporation. And the sun powers that evaporation for us in the water cycle. Freezing is very easy. No one in here is surprised by freezing when a liquid turns into a solid. We've all at least seen somebody fill up ice trays and they're liquid. You put them in the freezer and you pull them out a while later and now they're like ice cubes. They've turned from a liquid into a solid. Not very hard. Here's a question for you though. In all of these changes, and if I have that triangle on here, that would be awesome. Let me see if I can find that. There we go. Evaporation, condensation, sublimation, desublimation, freezing, and melting. What kind of change are all of those? Chemical change or physical change? I boil the water, Leah. I freeze the water. I sublimate it, desublimate it. It is. Every single one of those are physical changes. Who can tell me why they are physical changes? Grayson. And it's still the same thing, right? Whether that water molecule is close together as a solid, far apart as a gas, or flowing across each other as a liquid, it's still water. Every time I look at it, it's still water. I haven't changed it into a new substance, and that's something that's very, very important. So we think about evaporation. Condensation. If I go back to this condensation slide, there are, whoops, I went too far, I think. There are 3 times on a test that I think we're going to see the word condensation show up. Obviously, cloud formation is one, right? When water vapor rises into the atmosphere, cools off, and turns back into teeny tiny little droplets of water, that's cloud formation. What are the other 2 times that we're going to see on a test when there's going to be condensation? And you can use the picture as a hint or a guide. Yeah, what would the question or the answer be? It's not always cloud formation. Well, yeah, you have to give me the right answer. No, this is a class where I love wrong answers. No, give me another example of condensation other than cloud formation. Use the picture as a hint. I hope you've seen this recently. Otherwise, sit far away from me. Do what? You could have that on a window. On a cold morning, if you breathe on it, that's one. But that's not what I'm looking for. Yes. Hopefully, we've all seen that recently. You get out of a hot shower, and there's water dripping down the mirror because the steam, the water vapor from the shower hits that cold mirror, turns from a gas into a liquid, and it drips down the mirror. That's the same process that's going on here. What's the third way that they're going to talk about condensation on a test? Because it's not always cloud formation. You take a cold drink outside on a hot day and you put it on the table, whether it's a glass of lemonade or a can of soda. That can glass starts to sweat because there's water that forms on the outside of it. That is not the liquid leaking out of the can. That is the water vapor that is naturally in the air, whether it's from us breathing, plants, transpiration, evaporation going on. It goes by the can. The can is much colder. That water vapor turns back into a liquid, adheres to the can, and starts dripping down the can. That's why a lot of times you might have those koozies on your can, so it doesn't do that, and it keeps your drink cooler a little bit longer, right? Condensation. So, Henry, I can't talk about solids, liquids, and gas, and freezing, melting, sublimation, desublimation. I can't talk about all that, and I've already brought this up, that if I freeze water it's a physical change. If I melt ice, physical change, right? If it's cloud formation, like so you have condensation, physical change because every single time it's still water every time I look at it, right? I can't talk about that without Camden getting into chemical and physical changes and talking about these things a little bit closer. I'm not going to go through the video again. Number one, because we're making a video and that would be illegal. But I remember in this video, they were camping and they opened up the graham crackers. And the graham crackers were broken all into bits. Raise your hand if you remember that part of the video. Right? If I take graham crackers and I smash them into little bits, what type of change have I done to them and why, El? It is. It's still graham crackers, right? Now, in this same thing, they also were making s'mores and they were burning wood in the campfire. And the next day they noticed that the wood had turned into ash. Well, now you've formed a new substance. You can't go back and undo that. We call that a chemical change, and that's what we're going to review now. And we missed a lot of these today in our first rotation. So we're going to slow down in this. I was assuming too much that people understood this, and I think we need to go back over it. If I take a piece of paper and I ball it up, if I rip it to shreds, if I cut out a beautiful picture in the middle of it, Carter, even if I color on it with like a crayon, it's still paper. I've only changed it physically. I have not created a new substance. Even if I put it through the shredder in the office, it's still paper. Can I put it back together as the original paper? Not really. Taping it, yeah, it's not original at that point. But I can't, but it's still pieces of paper. It's not a new substance. That's the thing that you need to make sure. If a new substance is formed, chemical. If it's not a new substance, it is physical. And you need to slow down and ask yourself those questions. Again, I can cut out this piece of paper. No, I can't. I'm not that talented. But I can cut that out. It's still paper. Can I change that piece of paper back to the way it originally was? No, I can't. But is it a new substance? No, it's still paper. So it's going to be a physical. Whoops, I went too far. All of those changes that we talked about, melting, freezing, condensation, evaporation, sublimation, desublimation, or deposition, are all physical changes to water because it's still water. I have not formed a new substance when I boil water. Would it turn into a gas? It's just water in gas form. It's still the same thing. The molecules are just further apart. If you look at the molecules, they are the same. They just have different amounts of space in between them when they're a solid, a liquid, or a gas. So I think that part's important. I'll get your question in just a second. I know a couple of weird ones were dissolving salt or dissolving sugar in water. He said, well, that's new, Mr. Bullens. That's a tricky one. Can I boil the salt water and get the salt out? I can. I can boil water in a pan, catch that water vapor, let it condense and turn back into water droplets, and drink that, and it would taste like fresh water. What's left over in the pot would be the salt that would be left over. That's called desalinization. Very, very tough thing for us to do. Same thing for sugar. Same thing for sugar. It's not a new substance. It's just sugar molecules and water molecules side by side. You can separate them. It's tough, but you're able to do it. Chemical changes, a new substance is formed. A new substance is formed with chemical changes. Who can give me some reminders of other things other than burning to get to chemical change?